Hello students, welcome to Learner's Planet Problem Solving Session 3 of Acids, Bases and Salts. In our previous session we were discussing this question: why does dry litmus paper not show color change with dry HCl? Right? So I hope this question was clear to you, because in dry HCl there are no ions formed, and litmus paper for the color change requires the transfer of protons. So when the litmus paper is wet, water molecules provide that proton, whereas when it is dry there are no protons. Okay, now let's move to the first question of this session, that is, what is the role of toothpaste in preventing tooth decay? Right? So you should have remembered that we discussed about pH of saliva or mouth after meals. What happens? That the pH decreases. When the pH decreases, what will happen to the H ion concentration? It will also decrease or increase? It will increase. pH is less means H ion concentration is more. Right? Now what happens when there is acid in mouth or the pH of mouth is acidic? pH of mouth is acidic or is, say, 5 to 6, that is acidic. So this acid, what it will do? It will harm the dentine. Dentine is what? Dentine is a material of which tooth is made up of. Okay? It is basically calcium carbonate. Got my point? So when there is acid, what will happen? That calcium carbonate will react with acid and it will form a salt. Right? It's slightly acidic. You can't say that there is HCl or H2SO4. It can be any acid. It can be carbonic acid also. Okay? So this calcium carbonate reacts with the acid, forming salt. As the result of which, what will happen, students? That the layer of teeth will move on. Will move, right? And slowly the teeth will become thinner and thinner. Okay? As the layer of dentine becomes thinner, what happens? That the nerves gets exposed, which gives rise to sensitivity. Okay? Now, I also told you about pH of toothpaste. pH of toothpaste. What was it? It was on the alkaline side. That is, it was 8. Right? So when mouth is washed with the toothpaste, what happens? The pH of saliva comes to neutral range, that is 7 to 7.4. Okay, so what is the role of toothpaste in preventing decay? It is that it maintains the pH of mouth, okay, so that your teeth is protected. Clear? So this is a type of question which can be asked in your board exams. So you need to write very precise answers. Its answer precisely would be: the pH of toothpaste is 8, that is, it is slightly alkaline. After having meals, the pH of mouth decreases. Okay? That is, it becomes acidic. So tooth, which is made up of calcium carbonate, that is, it is a major proportion of it, reacts with acid, forming salt. Am I clear? So that causes tooth decay. Right, children? So this would be your answer. Now let's move to our next question, that is, what compound should be added to soil if its pH is 4? So what is this pH? pH is 4. It means what is the medium? It is alkaline or acidic. When pH is 4, the second one, that is when pH is 4, that is there is what? There is high concentration of H plus ions, right students? So this high concentration of H plus ions or acidic soil doesn't help in having good vegetation, or it harms vegetation. So the soil pH should be neutral, in the neutral range, that is it should be 7 to 7.4 or 5. Okay, now to increase OH minus ion concentration so that your pH is becoming 7, what should be added? pH you have to make it 7, right? So what should be added? You should add alkali. Now adding alkali doesn't mean that you are straight away adding sodium hydroxide, or I can write it here, alkaline substance, that will do. You can't add sodium hydroxide because that is going to take your pH to alkaline range or basic range. Even that is harmful for vegetation. So here what all other things added is, it is calcium oxide or calcium carbonate or calcium hydroxide, because these are weaker bases than sodium hydroxide or potassium hydroxide. Got it? So what will be added when pH is 4 or 5 or 2 or 1, that is on the acidic range? Alkaline substance like calcium oxide, like calcium carbonate, like calcium hydroxide. Clear? Now the next of this is when the pH is 9. pH is 9 means it is on the alkaline range, right? So when pH is 9, it is in what range, children? Alkaline. So pH is 9. This is alkaline. Right? To the alkaline soil, what should be added? Some sort of acid. But you can't add HCl or H2SO4 directly. So what can be added is decaying organic matter or compost. Compost is added. Now this compost releases H plus ions and makes the pH of soil in a neutral range. Clear? So when the pH is in the acidic range, calcium carbonate, calcium oxide or calcium hydroxide should be added, whereas when pH is in the alkaline range, what should be added is decaying organic matter or compost, which releases H plus ions. Right? Now let's take up our next question, children. Yeah, this is, what is the pH of given salt solutions? Right? Now this NaCl, what is it? NaCl is formed of a strong base, that is, it is formed of a strong base. NaCl is made up of a strong base NaOH plus of HCl, right? So the solution of NaCl will be what, children? Will be neutral. That is, it will have pH around 7. Right? Now the next question is, what is the pH of MgCl2? That is magnesium chloride. Okay, so will it be acidic or basic? Let's check out what it is. This is the first one. The second one, that is MgCl2. It is also formed from, of what it is formed, students? It is formed from the base, that is MgOH whole twice plus of HCl. Right? So of which HCl is what? It is a strong acid. Right? But magnesium hydroxide is a, what it is? It is weaker than NaOH. Right? That is, its basic strength is less than NaOH. So the solution of MgCl2 would be slightly acidic. Depending on the concentration. Right? So pH can be approximately 6. Because MgOH twice is also a strong base, but it's weaker than NaOH. Okay? Or its acidic basic strength is weaker than the acidic strength of HCl. Am I clear? Now our next solution is, what is our next solution? Na2CO3. Now what is that Na2CO3 formed of, children? Third one, Na2CO3. From where you have got this Na2CO3? Twice of NaOH plus of H2CO3. Now here, students, which is a strong one? The base. Okay, your NaOH is what? It is a strong base. Clear? And what about H2CO3, students? H2CO3 is a weak acid. Right? So what will be its solution? Its solution would be alkaline. And what would be its pH? It should be 8 to 9. Clear? Now our next solution is ammonium sulfate. Right? So of what this ammonium sulfate is being formed? What all are the acids and bases there? Let's take up this ammonium sulfate, NH4 whole twice SO4. Right? So of what this ammonium sulfate is formed, children? This is formed of ammonium hydroxide, NH4OH plus of sulfuric acid, H2SO4. Clear? Now what is NH4OH? It is a weak base. And what is H2SO4? It is a very strong acid. So what should be its pH, or what type of solution it should give? It should give you acidic solution. So what should be the pH? It should be around 3 to 4. Or it can also be 2. Depending on, I told you, it depends on what? It depends on the H ion concentration. Clear, children? So, depending on the salt, if such type of question comes in any of the exams like your Olympiad or your board exams, what you need to do is you just try to find out what that salt is made up of. What are the constituents? Whether it is a strong base or a strong acid, or a strong base and a weak acid, or it is a weak base and a strong acid. Depending on that, you can find out the pH of the solution. You can just give the range, right? Exact pH you can't find unless the concentrations are known to you. Am I clear? So you can just give the range, whether the solution would be acidic or the solution would be basic, right? Now let's take up our next question. Which solution will be more acidic? 1 molar HCl or 1 molar CH3COOH? Now children, what about this HCl? HCl is what type of an acid? HCl is a strong acid. Clear? So this HCl will dissociate completely into H plus ion and Cl minus ion. Right? So in the solution there will be large amount of H plus ion. Right? Now the another acid given here is CH3COOH, that is acetic acid. Right? Now where this acetic acid is found? It is in vinegar. Okay, so it is an organic acid and it's a weak acid, right? Sorry. So CH3COOH dissociates into what? CH3COO minus plus of H plus. Now in this case what is happening, students? Your CH3COOH is dissociated forming CH3COO minus and H plus. Again the CH3COO minus and H plus are combining and they are forming what? Acid again. So what will be the concentration of H plus ion? It would be less. Right? So which will be more acidic? What will be the answer of this question? Which solution will be more acidic? 1 molar HCl or 1 molar acetic acid? Which will be more acidic? 1 molar HCl. So what will be our answer? 1 molar HCl is more acidic than 1 molar CH3COOH. Right? Now you try to solve this second question. What is the second question? Which solution will be more acidic? 1 molar CH3COOH, that is acetic acid, or 1 molar glucose solution? Now let's again take up these things. I have shown you the dissociation of acetic acid, that is CH3COOH dissociates to give you what? CH3COO minus plus of H plus, and it is a reversible reaction, that is H ion concentration is less. Now take up another compound which is given here. What is it? Glucose solution. Right? So I'll write here glucose. Now just tell me, what type of a compound is glucose? Is it a covalent compound or an ionic compound? It is a covalent compound, right? That is, it doesn't contain ions. So it is not going to give H plus ions, right? It will not give H plus ions. Clear? So which will be more acidic, children? Your CH3COOH is giving H plus ions, whereas glucose is not giving H plus ions. So which solution will be more acidic? Acetic acid. Right? So what will be our answer? Acetic acid is more acidic than glucose solution. Glucose solution is in fact neutral. Okay. So whenever you are getting such type of questions, students, just try to dissociate that particular compound. Right? So your HCl, H2SO4, HNO3, these are all categorized as strong acids. Rest of the acids, carbonic acid and all the organic acids are the weak acids. Right? Carbonic acid, citric acid, tartaric acid, lactic acid, okay, these are all weak acids. If they would have been strong, we would have not been able to consume it. Right? So they are weak acids. Now let's move to our next question. Yeah. In what way universal indicator is more efficient than other indicators? So in my theory session I told you about universal indicator. What is universal indicator made of? Universal indicator. So what all it is made up of? It is made up of all the indicators, है ना? So many indicators, or I can say many different indicators. Many different indicators are mixed, right? So many different indicators are mixed to make what? Universal indicator. Fine? So your normal indicator, what it does is it only tells whether the substance is acidic or basic or neutral. Clear? But universal indicator gives the pH. Right? The makers of universal indicator provide you with a strip. Right? Now this strip has got, this strip shows different colors at different pH. Say it is showing red at pH 1. It is showing green at pH 7. It is showing blue or violet at pH 10. Right? So this universal indicator has got pH from 1 to 14, or the strip has got 1 to 14 pH, and at every pH the color of indicator changes. Clear, students? Now this type of strip is provided with the soaps. You must have seen the ad of Dove soap or certain oils or shampoos. They show the pH of that particular compound. Right? This pH strip is very, very important. It is used for checking the pH of soil or other chemicals also, other things also. right? So which is a more efficient indicator? Universal indicator or other indicators like methyl orange, like phenolphthalein? Which is it? Universal indicator. Why? Because it gives the indication of pH, right? It tells you about the exact pH. It shows color change at different pH. Clear? Now our next question is, what are the positive and negative ions of following compounds? Sodium nitrate and potassium chloride. I think it's a very easy question. You can just, by seeing the compound, now you can make out the ions. Say what all are here. Here is Na plus ion. Sodium is a metal, so it is forming what type of ion? Positive ion. And there is what type of ion? NO3 minus ion, right? Now could you guess what all are the acids and bases here? If it's Na plus, the base would have been NaOH. If it's NO3 minus, the base would have been, the acid would have been HNO3, right? So it is a salt. Likewise your KCl. KCl would be potassium plus ions and chloride minus ions. So students, what all are the acids and bases here? Acid would have been HCl and base would have been potassium hydroxide. Clear? This solution would be neutral. This solution would be what? Neutral again. Because both are strong acids and strong bases. Here your base is KOH and acid is HCl. And they will give you what type of solution? Neutral solution. Right, students? So I'll conclude for this session. In this session, we discussed questions related to indicators and to the acids. In the next session, we will discuss few more questions of acids, bases and salts. Now these questions, students, these are relevant for competitive exams like NSO if you are giving National Science Olympiad or your board exams. So do practice these questions. Okay?